is about how does boiling occur in zero gravity. In 2009, we applied to NASA's reduced gravity experiment opportunity, and we were accepted. We built our project. We were able to take it down there to NASA. We had this really thin platinum wire. We'd use that to boil and also study how heat moves on that wire. There's a few issues that we had. We decided to try it again. We needed to make changes, see if we could use some of last year's results to come up with this idea of using a heater to cool things. The team last year had been studying the design process in class. We decided to try and apply engineering design to revamp FUNBOE.
One of the most important steps of the engineering process is to identify your problem or set a goal and find things that you have to fix. One of the biggest problems with last year's experiment was that we had to switch the cells in and out. We found that a lot of us were getting sick. So we devised a way so that the cells were stationary, and by doing that, none of us got sick. We wanted to have multiple geometry. With a new experiment, we were able to test chip heaters with some new hypotheses.
Each week, our team would meet to check up on our schedule and make sure that we were meeting our deadlines. And it was really important that each person completed each assignment that they were given in order to complete our project by the flight, which was in June. It was really important that we worked as a team in order to get that done.
The unique idea in FUNBOE 2.0 was to advance boiling research towards application. Rather than just study the forces, which we're doing with our thin wires, we are trying to implement a new idea of using microchips as cooling devices. You can actually start to develop cooling systems. So that takes a lot of brainstorming at first. You have to do prototyping to see if it would work. We had to prototype movement systems for our cameras and how to secure each boiling chamber in our structure. We had to prototype it to figure out what would work.
The reason that we decided on the structure that we did is because last year that we had a big issue with people getting sick. That made it very difficult for us to get the data that we needed. And so this year we began with a design that was a kind of a Ferris wheel idea where we would turn the cells into place, and after a couple of design reviews we recognized that was far more mechanically complex than we really needed. A linear system would be much better, where we'd fix all the cells so there'd be a lot less motion, a lot less opportunities for error. We were able to verify that it met all the safety standards that NASA had to make sure that our experiment was not only structurally sound for the cell, but also that it would be safe for all the operators of the experiment.
Being on the gas team, we had the opportunity to go out and teach younger students about science. I really like this a lot because we have the opportunity to inspire young minds, to be that person that you always looked up to growing up, to kind of help them get excited about math and science and reading, because as a kid those things aren't necessarily important. Another important thing is whenever you do research you have to let people know about it. You have to get people excited, and the way we do this is we go out and we tell people about it. We share our experiences, and we also have the opportunity to be published in newspapers and magazines and things like that.
Once we finished building FUNBOE 2.0, we shipped it down to Houston. We were ready to implement it. We still had a lot of issues. One that came up in the test readiness reviews that we had to seal below our boiling chambers to contain the water if there was a leak. We had to take the whole project back to our hotel room because we ran out of time working on it in the hangar. The flight was actually a tremendous success because we had a lot of things that we weren't sure how it was going to work out, but we did get everything working as it was supposed to, and on the flight we just collected a tremendous amount of data. So it turned out well for the experiment in the end.
Once we returned from NASA, we immediately began analyzing the data we collected. We have found much success with FUNBOE and have already begun sharing that. Throughout the year, we held an outreach activity where students would build paper airplanes, and we wanted to show them how they would react in zero gravity. We've also been sharing about how we use the engineering process to help us build FUNBOE. I just love seeing how excited kids are to hear about our experiment. The next step is to evaluate and redesign and to once again improve FUNBOE. And now that we have a stable structure, We want to figure out a way to get the microheaters working. And engineering is just like that. It's one continuous cycle. And RGO has really taught me the importance of each step in the design process. I was able to apply what I was learning in classes to a real-life situation and have gained experience that I couldn't have found anywhere else. We are doing things that will have an effect on our lives, our country, and our world. We are making a difference.